Figure 3.1 shows a ramp being used to move a load which has a mass of 180 kg onto a lorry. The ramp is 4 meters long and the end of the lorry is 1 meter above the ground. A force of 600 newtons is needed to pull the load up the ramp. Take gravitational field strength, which is G, that is equal to 10 newtons per kg. So we've been given this diagram. Then the questions are as follows. Question A, calculate 1, the gravitational potential energy gained by the load as it goes from the bottom to the top of the ramp. Part 2, work done by the 600 force, 600 newtons force in pulling the load up the ramp. Roman numeral number 3, the efficiency of the system. Then part B, the load topples off the lorry and falls to the ground. What is the kinetic energy of the load just before it hits the ground? So this is the question that we're going to consider in this video. Remember to subscribe and turn on the notification bell so that you can have access to these videos. This question is on number 3 in physics paper 2 2016. In order for this load to be loaded on this lorry, they used a ramp system. So this is a ramp, and then this load is given this force so that it can come here. Now, there is a great significance in collecting the data before you begin answering any type of question. And most of all, it is very much important to understand the question first, then you come up with the data, and then you need to use that data so that you plug in the necessary equations to solve the needed solutions or to come up with the needed solutions. So here what we're going to do is we're going to collect the data. We have the mass, 180 kg, which is this one, the load. Then we have the force, which is 600 newtons. What else do we have? We have the distance along the force. This force, 600 newtons, which is, let's call this X or D. Okay, 4 meters. What else? We have the height from this point to this point, which is height, H, 1 meter. Now, having collected the data, we need to look at the questions that are needed to be solved. Here we have, for part A, we have been told to calculate the gravitational potential energy, then the work done by the force in pulling the load up the ramp, and then also find the efficiency. And B, if the load topples off the lorry and falls to the ground, what is the kinetic energy just before it hits the ground? So these are the questions that we're going to handle. Now, let us proceed as follows. We know that potential energy, so we say solutions. Let me erase this part. Okay. Okay, just this. We know that potential energy is given by or is equal to mass times gravitational field strength times or acceleration due to gravity times h. So using the data that we've collected or the data that we've been given, here the mass is 180 kg. So we forgot something about this. Then G, which is G, is we've been given it to be 10 newtons per kg. So for this, then we have 10 newtons per kg times 1 meter. From this point, this one is going to be 180 times 10 times 1, which will give us 1,800. The units for potential energy, it is joules. It is joules. So 1,800 joules. This is the first part, which is the A1. Let us go to A2. Work done is given by force times distance, and the distance for work done, it is actually the distance that is in the direction of the force. So here, the distance in the direction of the force is this one, which is 4 meters. So we have work done, so this is the second part. Work done is equal to force times distance. And distance here, it is the one which is 4 here. So we can also write it as force times distance, which it is one and the same thing. So here we have got this force, which is 600 newtons, 600 newtons times the distance 4 meters. So this one is going to give us 2,400 joules. Then the other question, or the third part of question A, is requiring us to find the efficiency. Now, efficiency is given by the work output over work input times 100. So this is the percentage that is expressed in this form. Then the work output is actually the work that is done. Work output is the work that is done in moving this from this point to this point. And here, the work output is done in moving this load. So from this point to this point, so from this to this, which is this one, 18. So we have 1,800 joules, or 1,800 joules over this one, which is done in moving this one from this point to this point, which was used to move this one, as in raising it a distance of 1 meter. To raise this is what we call the work input, which is 2,400. 2,400 joules. So this is times 100. So here, what we're going to have is, so this and this will cancel this, and this will cancel, and what we're going to have is 18 over 24, which can further be dealt with in this way. So 6 in this, it is 3. 6 in this, it is 4. So we have 3 over 4. And finally, so this is times 100. So what we're going to have is, this is 75%. The reason why we multiply by 100 is because we want to express it in terms of percentage. And this is the value for the efficiency. Now we have the last part, which is demanding us to find the kinetic energy when it falls off the lorry and it begins to go down. Now, just before hitting the ground, we are told to find the kinetic energy. So let me erase just this part. Okay, so kinetic energy. So we know from the energy of energy conservation that energy can neither be created nor destroyed, but can only be converted from one form to another. So we have got this, when this load comes here, when it comes here to this distance, 1 meter, and then it accidentally falls, okay? Here it has got some energy, which is potential energy, and when it falls, the energy, this energy is going to be converted into kinetic energy. And just before hitting the ground, this energy and the energy that it is going to have here before hitting the ground, it is the energy that is equal to this. And when it begins to move, the energy that is going to possess is kinetic energy. So it is going to be from energy conservation principle. Potential energy will be equal to kinetic energy. So for this, we can conclude to say we know that potential energy is given by mgh, and of which we even calculated. So this one will be equal to kinetic energy. And kinetic energy that we calculated there, the potential energy that we calculated was 1,800. And just for the sake of confirmation, we can say this one it is 180 kg times 10 newtons per kg times 1 meter. So this one it is going to give us 1,800 joules as the kinetic energy just before the load hits the ground. Thank you so much for watching the video, and for this and more, make sure that you subscribe and also turn on the notification bell so that you can get updated every